Hey, what's up? I hope I'm clearly audible. Yeah, I got a really bad earphones, man. Let me check it on my phone that, yeah, if I'm clearly audible or not. Hey, what's up? Hello. Hey, what's up? Yeah, sounds good. So yeah, sure, let's move ahead with today's live session. So yeah, I have been building, yeah, I have got this a boot.dev. I got this from a student GitHub pack, which were offering like a 3 months of free subscription for the developer students. So yeah, I think I have enrolled in this. I think it has been like a 15 or 20 days so far. And yeah, I'm really liking this platform, but I haven't really explored it. I feel like this, I'm good at languages and all. These are like pretty basics that I have to complete. So yeah, I don't know if I should complete it or not, or move ahead to other advanced topics. Yeah, I think that sounds the right strategy. So yeah, today, I mean, whatever, today we're gonna learn about Docker. Uh, let me type in, let me open Eraser. Eraser. Let me open a whiteboard. Eraser. Yeah, it's a really good platform wherein it's the most popular whiteboard out there. As well as there's Excalibur, which is free. Eraser is paid. So I have it set up there. So instead, I should why not start in here, right? So today we're gonna learn about Docker, Docker technology, and what it is. Uh, I have gone through, I mean, I have researched about it a little, but yeah, sure, I'm gonna complete this or learn about it online using the subscription I got. Yeah, I will be completing this course, which is Learn Doctor. So yeah, I will be completing this course. Um, Let me go into the details of it, like what are the contents and all. Yeah, it's 18 hours of content. Yeah, and 43 lessons. I will be trying to do a live stream or yeah, similar kind of what I'm doing right now. Whenever I will be learning this on this platform, I'll try to post it online and do similar kind of live. So yeah, you must be asking, like, since I have enrolled in this course, so why I'm directly jumping to the Docker and why not completing and this with the courses in between. So let me tell you a bit about myself. I'm a software engineer. I mean, uh, engineering student, IT engineering graduate. So I have experience building software. I have good knowledge of the technologies, languages like Python, TypeScript, JavaScript, and all sort of things. So as well as working on the development process. So I do have the knowledge of it. But as a software developer, as a junior or a graduate, I have dealt with a Docker, but not deep dived into it. You know what I mean? Like I know the overview concepts, like why we use it and how to uh, spin up a Docker, or if I get a Docker, how to spin it up, or and just a very small basic things to configure. For yeah, but now I will be deep diving into it and clearing all of my concepts, uh, getting hands on to it. Uh, so yeah, and you must be asking why right now. Like yeah, it is really important. But yeah, let me why not share with you what I'm trying to build. So yeah, I'm trying to build a P. I was planning to build this platform, which is yeah, which is called P2P interview. Sorry, interview platform, wherein what it offers is uh, basically allowed two users. Uh, yeah, yeah, I think that this Excalibur does not offer a lot of icons. That's the drawback that I feel. So yeah, whatever. So what I offer is on this platform, what I'm planning to build is I will offer users, user A and the user B, a platform to connect with each other, uh, and they could take each other's interview. And as a platform, my job is to connect them together as well as provide an interface or the underlying infra to conduct the interviews. For example, in an interview, it would be P2P, right? So I will connect them with a P2P architecture using WebRTC, so which will also not cost me. So as a fellow student, graduate developer, it would be also easy for me to host it. And yeah, why I'm telling you all this is because there comes the problem or the issue, not the problem but the feature. So as the typical interview workflow goes in, the really important part of any interview is technical questions, not the questions but the coding part. So on this platform, I will be providing a lead code style, the lead code style layout, wherein it will have code editor here, problem and test cases, that sort of thing. So to run this code, I will actually have to build something similar to these platforms, like uh, what code chef offers, like what code chef has, or let's say what lead code has, or hacker rank. So similar to these platforms, I have to also build a similar kind of logic or infra wherein I will give user this interface wherein they could execute their code. So here comes the problem of the code execution. So there are a lot of public APIs that offers this, but but they offer like only 50 requests per day. So that is when I have this idea, why not build my own code execution? Why not build my own code? And not the code, but the exact name is, or the what the referring industry is, remote code execution. So yeah, I thought why not build this of my own, and here comes the challenge of it. So to build this, I have to have API layer knowledge, which basically is responsible for handling API layer, which accept the request, uh, of processes or run the code in the background, and I will have a response. But this is not really difficult because I already have knowledge about it. The main layer is code execution process that has to be on server. So that means Linux come into picture, as well as to build this, I have to have, for the security reasons, I cannot run the actual code on our host machine. I have to create something called containerization. Containerization, and to achieve this containerization, there comes different architectures of it, but the really popular and easy one is, for what I feel easy one is Docker. So yeah, that is why I have switched directly to the Docker course. I mean the Docker course while skipping all this in between just because of the project. And yeah, so now I have explained what is the context for how learning Docker right now. Yeah, let's move to the course then. Shall we? Yeah, here we go. Docker is a big naming containerization. Yeah, as I told, containerization. I think, as the name also suggested, containerization basically means, I guess, uh, isolation. I feel it means isolation. How can I split it? Split the, yeah, really cool, bro. Uh, so, mm, yeah, let me take a note here. Good, cool. Let's put this now. Okay, so yeah, pro containerization. Yeah, so what I feel is, I think as the name suggests, it basically means uh, isolation. that we create a new environment that uh, acts or execute or try to act like an different from the actual operating system or the actual machine, just to mimic some environment. Yeah, that is to achieve this isolation. We have something jargon word like containerization. As the name suggests, we create something container which that whatever code inside cannot uh, connect or interact with outside of the container. So a container is basically just like this. So whatever inside cannot be interacting or should not be interacting with the outside. So yeah, that is the containerization which I feel. Yeah, let me just search it on. Okay, container. Where is this thing? Yeah, the big idea behind Docker or the container technologies is that they allow us to package our programs with an environment that fit the whole thing. Most most real world programs begin working isolation domain of file founders, environment, variable, yeah, special information that image container have become standard for developing application. In this course, you will learn about Docker and containerization. So, for Windows, yeah, I have WSL too. Mm, so that is when the page which is, yeah, I can install it now. Okay, I have to install boot.dev CLI. Okay, what the hell is this? Okay, this can be next command. You just run and your turn. Okay, let me try one. Oh, where are all these things are opening? I think this has to do with the war. Let me turn this density further on. Okay, so to install this boot CLI, um, you- okay, I have to do this right. How to open a terminal? What's command line? Not a conversation. Mm, Bro, this is so confusing. Run Ubuntu. Let me close the this video. I feel this war under the hood runs some kind of really small AI or LLM model. That is why it lacks so much on my device. Do you have any users watching it? Hello, people, what you mean? Yeah, bro, work is using all of my resources. I think under the hood is doing very good. Let me just run my Ubuntu directly from a default CLI. Work is crazy, bro, especially for a low-end device. Well, there was an IPL match that I had to watch because of my favorite current team of this IPL is playing. Yeah, that's good that Hara is batting. Not right now. Okay, containerization is a way of packaging an application with everything it needs to run, such as code library configuration for the unit is called container. Okay. So basically container is package which include everything it needs to be run a certain code or process or application. Okay. Why it matters? Because app and dependencies travel together, run consistently across different environment laptops, desktops, cloud platforms. Today, okay, container versus virtual machine. Containers are lightweight, virtual machine without they do not share the bundle full of folders inside each one inside the share. Oh, yeah, this is really important point that I want to talk about. Before, let me just do this installation process. So yeah, since we are in our Linux WSL, oh, how do I test it? Testing. How do I paste something like okay. Goal basically just a command line tool to browse the internet. So basically, if you do call google.com, it will basically get the HTML CSS that is return. Or if you do in this specific URL in case, it will return a downloadable file because this URL contains downloadable file. This is a pipe that means after this command finish, sh page, and that means run it. I think these are the flags. I don't really remember all of this. Okay. Welcome to Webby, a modern tool and called what the hell is Webby? Okay. Installing Go tool. Okay, so I think it just installs the Go. Install Go. Okay. And then Go version 2. Okay. Go version. Okay. Okay, now how to install the I think it is made up on Go language. So that is why I have to install Go. Go. I don't think I have Go installed. Okay, I have to follow this instructions, right? Downloading, save, installing, install Go. We did this path to add local thing. Okay. And I have to add this path to those. So, considering downloaded, the path is not set. You can very much how to run this command. Don't worry, I don't even know what this also means. Okay, run on Then there's food, but mask, there's this. What the hell is this taste? Now I have to go cool, go install boots while I let this. Damn, so yeah, we're into half an hour into the stream. Yeah, let me just basically explain how Docker is different. I mean, we all know what is Docker used for now, right? I mean, I mean, it could be used for different implementation, but the very main as a developer is to uh, to create an environments that actually, for example, we have this massive headache of sharing coding environments, right? So we can be for in team environment or as well as server environment. Most of the servers are in Linux, and most of us we use Windows, Mac for coding environment, as well as if you're working in a team working development, we might not have same environment like same version of everything or same underlying infra to run specific processes. So that is wherein this Docker comes in, which says that yo, I could create a similar we could create an image on of any of anything. Mostly it would be an Ubuntu or Linux operating system, uh, wherein we could create our own. It would contain our source code. It would have our, for example, let's say our source code required Node version 18. We could also specify that or install that. If we required Python version 2.8, that will specify that. And instead of the sharing code, we could just containerize our coding in this Docker environment or Docker image, and we could entirely share this Docker to anyone, and it just have to run this Docker image. We have all the scripts ready, and so it would basically just install this on their environment. Yeah, this is the main implementation for developers to share same coding environment. So if let's say I develop this on Windows and I create this specific Docker image, and now I have to let's say host this application on Linux server. I could just basically take this Docker image, just run few commands, one or two, to execute this Docker on Linux server, and boom, we're already we have shared same exact coding environment. Because of the we are running this process in our container environment, which basically is preset. It does not interact with outside what it is. So outside it doesn't matter. It could be Mac, Linux, or any other system. So this is the very basic use case of it. And yeah, but let's talk a little bit in detail about what are you will be you will also interact with virtual machine or let's say Docker. So what is Docker and how different it is from virtual machine? If you are if you were curious in your, before, you must be. you must have installed virtual machine Linux or Mac or Windows on your different operating systems. You must have noticed that how this virtual machine actually works is there's some hardware, right? There's some hardware uh, on top of it, the our operating system or kernel that in some cases we call it that runs on top of it. Let me fill it with this. Let me with this. Yeah. This is hardware and this is operating system which runs on top of the hardware, which could be anything, Windows, uh, yeah, which could be anything, OS, Windows, or, or Mac, or Linux. Yeah, it could be anything, and this is and hardware on top of it. This runs operating system. So you could say operating system is a subset of hardware. Operating system cannot run without an hardware, but hardware can exist without an operating system, right? Similar to that, uh, when we install operating system, it mostly cover all of our hardware. It use all of our hardware. So, but when we use virtual machines, so what this underlying technology does is, I don't remember, I think it's something like uh, hyper something, which is called, in which uh, we actually install, you must have installed the in virtual machine, you must have installed different operating systems. So it directly install those operating system directly on our hardware. So if you install, let's say, Windows for Kali Linux, which is a Linux type of Linux, it would directly install that on our hardware. So separate from our operating system, directly install on. So it has nothing to do with the our operating system, which is native. It will directly install on our hardware. So yeah, uh, this is, and we could actually specify how much of this virtual machine will have access to how much of hardware part. We could allocate like a 30% or even 50% of the hardware to our actual virtual machine. But the problem here is it is really big. I mean, we are literally just installing, uh, we are just shrinking our main operating system. We are just installing new operating system directly on hardware. So this is really resource consuming. This is uh, really heavy in size. Resource consuming, time consuming, and yeah. So this does not make sense if you are looking for solution for containerization. That means saving our code. We cannot just share this virtual machine. It would be like 30, 50 GBs just to run a one simple code. Saving this entire would be so stupid. Or it does not make sense. So here comes a Docker which solves this exact problem, wherein they say in Docker systems, what happens is they say this is our hardware, right? So if this is hardware and we have an operating system running on it, let's say which is Windows. Instead of installing new operating system or virtual machine directly on our hardware, we basically install it on the native operating system. So this is basically and Docker. This is basically the Docker, and this is the Docker image or container. So it basically installs container on top of the Windows. So basically, this uses kernel of native OS. So this makes sense because this is fast to spin up new new containers because we are not actually dealing with the hardware. We are dealing with the operating system part with, because there's only one kernel and we are just containerizing on top of it. So yeah, we could with this we could create as many containers as possible. We could create as many containers as possible. That is why this is called Docker. It is easy to spin up, easy to clean up. So yeah, I think I must install the boot.cli. Boot, yeah, I think it's all good to put up. Okay, boot login. Okay, I have to paste my code in here. What code? What code is that? Okay. Okay, logging down. I have to run this to complete this assignment. Okay. Yeah, I guess this is what I can do. Next session. If you are on to okay, this done. Let's move to the next. Oh, okay. So install Docker server. There are a couple of ways. This is to request, okay, Docker server or Docker daemon. But, this listens to request from, okay, Docker daemon is really important thing to note on because I think it's just a jargon for server that they use and they use it a lot. Yeah, typical IT behavior, the typical tech behavior. They love to use jargons. Okay. This listens to requests from desktop app and this execute them. This is basically just a main server. This agent if this agent fully running, nothing else will work. Okay. This is like a brain, the Docker desktop. It's just a GUI. If it doesn't have installed, if it is just really in Docker. The important thing is Docker server or Docker daemon. Starting the GUI should start the server. Okay, just an interactive way. And the Docker CLI, as a developer, you will interact with CLI, I'm recommend using GUI. First command line as well. Install Docker. I have okay. Run Docker. Okay, sure. Should it show green? Yeah. Docker. Okay. It is running. Okay. Docker. Like I have a Docker installed to greater than 4. The just run commands and just put double click, right? Hmm. Let's move to the next. Docker Hub. Okay, like GitHub. Official cloud store service. Sharing Docker images. Will talk about them like a chill place. Okay. Will use Docker Hub in the space. But there's other popular tools as well as AWS, ECR, GCP, Azure, GCP. Let me just check it out. Amazon container, elastic container registry, rising, so it's a bit big. Okay, I could have registry, which is also the legal type stuff, and the special for the what's the your home, your home from the media, real deeper, and real system. Okay. I think they're offering something for free, right? Not AI related. Why not register as well? Okay. They, that's what do you mean? Okay. Create a free account. It's a account local connected to Docker Hub. Hopefully, it's much easier. Okay, the one which will log in. Stock up. I'm not in the register. Okay, let me just sign in. They are also living this that negotiables and increase mutually on and this have been yeah, it's looking tough for our end. Don't know. Definitely run this to complete this assignment. Um, okay. Okay. Container is a standard unit of software that packages the code and all its dependency to an application runs quickly gradually from one computing to another. Okay. We had virtual machines, like virtual work for a long time. The trouble with VMs is that the slow as like booting up usually takes longer than physical internet. On the other hand, is 90% of the benefits of virtual machine and the super like containers booted in second. Yeah, this is the main thing which I was talking about how different architecture of the VMs virtual machines and containers are. There's a 90% similarity benefit of virtual machine, but they are super lightweight just because of the architecture. They use operating system, main operating system kernel to run them. Instead, in virtual machines, directly run on dedicated hardware. So it has their own operating system, everything that they install from scratch. Okay, the VM architecture. Yeah. Infra hardware, hypervision, which I was talking about. On the okay, biggest operating system, I think on the virtual machine, cool, of container architecture or infra host operating machine, and on top of it, even Docker could initialize this containers. Why are containers like that?
Containers aren't specific to Docker, though Docker is the most popular containerization platform. Containers are kind of like virtual machines, with a couple big differences. So first, let's talk about physical machines, and then we'll understand how everything works kind of from the ground up. Computers need hardware to operate. Think CPU, RAM, and disk. On top of that hardware, we install an operating system like Mac, Linux, or Windows. The operating system interfaces with the hardware and handles low level tasks on behalf of the applications that it runs. Within the OS, we run applications, things like Google Chrome, Discord, Slack, or even a custom web server. Really, anything that you'd use on your computer. And this setup works great on a local machine because all the apps can talk to each other. You can trust them, and usually that's what you want. You might want Photoshop to be able to edit an image and then be able to import that image directly back into Premiere. But if you want those apps to be isolated for security or other reasons, the operating system alone isn't really the solution that you want. Imagine you're a cloud provider selling access to server hardware. Your customers use your hardware to run their backend servers, but renting one full server could cost like, I don't know, $100 a month, which is really expensive if all you're doing is, say, hosting a static site. Virtual machines, or VMs, solve this problem by allowing you to split a physical machine into smaller, isolated virtual machines. So, for example, if a machine that you rented cost $100 a month, but you're able to split it into 5 virtual machines, now maybe each can be rented for just $20 a month. And each virtual machine's operating system can run its own applications. And those applications are isolated from the other applications running on the other virtual machines. Now, the big issue with this is that VMs are actually pretty resource intensive. Each one runs its own full operating system, which adds a lot of overhead. So if you run 10 VMs on one machine, a lot of resources are going to run those 10 different operating systems. And containers solve this problem. They maintain the isolation that VMs provide, at least for most use cases, but they share the host operating system. So they avoid the performance overhead of multiple full operating system instances. So instead of hardware, many operating systems, and applications, we now have hardware, one operating system, many containers, and then applications inside those containers. This architecture allows isolated processes to run much more efficiently. Now, containers aren't always the best tool, but if all you're trying to do is run isolated processes, containers are usually a better fit than full VMs.
Yeah, pretty good explanation. Yeah, which is an underlying operating system. Okay, virtual machines. Okay, does not share the the underlying OS. They install their own directly on hardware just above the hyper layout. So yeah, virtual machines does not share underlying OS. Docker containers does images. So containers are kind of lightweight VMs. So what is an image? Image is built on the definition of container. Instance of virtualized real-world environment. Okay, so explaining this, what is containers and what are images. So basically, a very great example would be, let's say you have your own laptop, and on top of it, you run your operating system, right? If OS could be anything, it could be math, it could be Linux, or anything. Just like that, the I mean, for everyone, this is same, but the version depends. The version changes. I mean, this is just a piece of code or read only, right? It runs on top of your laptop. You could also say, yeah, this can be referred as you can draw a good diagram. Okay, so this can be referred as containers, and this can be referred as images. So you could say containers are just a process of something. If you could have multiple laptops in this nationalist same environment, and on top of it, you could run one single image on each instance of it, right? So yeah, this is a great example that you could visualize images as operating system, for example, that runs on your machine or laptop, and laptop we could consider as a container and operating system. Uh, Images are read-only. They just run on top of containers, and we could have multiple instances of containers. Read-only definition of container is goes like read-write environment. Container is basically an image actively running. That's two words. Let me think about that. Maybe containers are just basically image that actively running. Now, if you put up containers on an image, you can create multiple separate containers all from the same image. So yeah, as I told you, image is like an operating system. It just at the end it's just a code, right? Operating system is just a code that we install on containers. And what is the we just an active version of image. Okay, it's kind of like a relationship between process and object. You could say image or
Let's talk about Docker images and Docker containers. Say we're building an image for WordPress, popular blogging app written in PHP. Inside our image, we need to include everything that WordPress requires to run. So that means things like the PHP interpreter, a web server, probably Apache, the WordPress application code, and maybe a database like MySQL. We also need to define the operating system it runs on, typically Linux. Once we've bundled all of that, the base Linux install, the MySQL binary, the WordPress code, and the PHP interpreter, into an image, that image becomes read-only. Its state can't change. So, for example, if someone uploads a new post to our WordPress site, that change doesn't make its way into the image. So, what's a container? Well, a container is a running instance of an image. When we use the docker run command, it creates a container from an image. If the image is named WordPress, we'd run docker run WordPress. And that command gives us a new running container with its own unique ID. So the image defines how the software runs, and the container actually runs it. When the container starts, it launches the WordPress application, and if we connect to the container, we then get a working website. And unlike images, containers are read-write. So once a container is running, it can write data to disk and interact over the network and stuff like that. But we're not just limited to one container. We can use Docker run as many times as we want to create multiple instances of different containers from the same image. It's like opening multiple tabs in Chrome. So why would we want to run more than one container of the same image? Well, usually it comes down to scale, especially for backend systems. At boot.dev, we often run between 4 and 10 instances of our backend API. When more and more users connect, our backend automatically spins up more and more containers, so the load gets spread out evenly and doesn't overwhelm any one server. When we update our backend code, we push a new image and then start fresh containers from the new image. So remember, containers are stateful. They're running instances of an image, and images are definitions of the app and everything that it needs to run.
yeah, I think I'm angling is doing an energy to continue this. Okay, Dr. House, I will put it down onto your looking see. It's like It's just like GitHub. You could just flow. You just like cloning a paper. Okay, I'm done. I don't have this energy to continue with. Um, so, uh, why, guys?